चलो दोस्तों शुरू करते हैं without wasting a time. In the last couple of video, we have seen that how split Trojan rule work in the case of IBGP full mesh and why do we require a full mesh peering in case of IBGP. We also seen that how to configure BGP route reflector with the same cluster ID, different cluster ID, and what is the use of originator ID, and what is the use of cluster ID. We have seen also with the BGP update messages how originator using a originator ID and how cluster ID in action also. Similar way, we also discuss about the failure cases when we have done the lab with the BGPR with the different cluster ID, how we can stuck with the dual failure situation. In this video, we'll discuss about the what is the advantage of BGP route reflector. So I have mentioned the two major advantage of the route reflector. One is the less number of IBGP session we require if you use the RR. Like we know in the case of IBGP, full mesh is required and but with the help of RR we can reduce the amount of peering required, and we can also calculate the how much what are the numbers of peering required in case of full mesh with the help of this formula. And second update, we can say the less number of BGP update. When I say the less number of BGP routing update means, let's suppose we have this prefix 100.100.100 and it's coming from this router also, from this router also. This router is connected with the cell site router 3, this router is connected with the cell site router 2, and both these router are the client of this RR1 and RR2. Okay, so both will send their this routing update to the route reflector one. Okay, and route reflector will run the best path algorithm. Let's suppose route reflector have select this path as a best path. So he have selected this prefix, and next stop is the this originator ID as a best path, and this is the backup path. So route reflector will only send the best path to their clients further. So he have got the two update. He have got the two copy of the route. One from the next of this 2.2.2.2, and next second is the next of is the 3.3.3. And after that, RL with the best path calculation. After that, let's suppose he have selected the best path, which is coming from a router 3.3.3. So router reflector will only reflect the best path to this client CSS1 1.1.1. Okay, so after that, let's suppose something happened with the topology, something happened with the network. Let's suppose this link went down from the CSS2 to this XRV router, and after that, what will happen is, so this client router will set the BGP withdraw message route reflector. So route reflector will withdraw this backup route which was coming from the CSS2. But this update will not go further to the CSS1. That is not required because the route reflector only reflected the best path. Okay, so with the help of this way, we can say that with the using of RR, there will be less number of BGP update on the client. So let's see the BGP update in action. So first we will verify the routing, the BGP routing table for this prefix on the route reflector one, and we'll verify that which path route reflector one is selecting best. So this will be selecting the one best path either from the CSS2 or either from the CSS3. And after that we will shut down the interface for the known best path. Like if RR1 is selecting a best path from the 2.2.2, so we will shut down this interface which is between the CE device to cell site router 3 and vice versa. To so here I am in the route reflector 1. Let's check the BGP table for the prefix 100.100.100. So we can see that we have a total 3 path available, path 3 available, and one path is coming from the CSS2 cell site router 2, and one path is coming from the cell site router 3, and one path is coming from the route reflector 2. Okay, and if we can see that is selecting a best path is best path path 1, so it's selecting the best path from the route from the CSS2, the group best. This is the group best path is selected. Okay, so I have enabled the debug BGP updates on three routers on the on the two routers on the route reflector 1 and on the CSS1. Now what we'll do, as is selecting a best path from the CSS2, so we will shut down the interface from the cell site router 3 which is connected with the customer device CE device. Okay, and after that we'll verify what are the BGP updates in the show logging table we are getting on the router sector 1, and at the same time we'll also verify the BGP updates in the cell site router 1. Let's jump to the first on the cell site router 3. As cell site router is not at the best path, it's selecting a best path from the router from the CSS2. Okay, so let's jump to the CSS3. So here we are on the cell side router 3. Here also enable the debug BGP updates. Okay, and we can see that we have an for total 3 peerings. 2 peering with the router vector 1 and router vector 2, and one is the eBGP peering which we are running with the customized device. So what we can do, let's do the show route here for this neighbor IP, and we can see that this is the interface. Let's shut down this interface. Interface key gap ethernet 0/0. Let me do the shutdown. So here we are again on the route reflector 1. We have shut down the interface of the CSS3 to CE edge device, customized device. Let's again check the routing table, BGP table for the professional. Now we are getting the only 2 paths. Earlier there was a 3 path available. So we have shut down this path, known best path, because this was not best. BGP was selecting this path from the CSS2 as the best path. So now we have shut down the path which was coming from the 3.3.3. Okay, if I check the show logging, as we already enabled the BGP update, debug BGP update, so we can see that here we are getting a BGP withdraw message. You can see that here we get an update from, this is the originator router, okay, which were early sending a message. He have sent for this prefix BGP withdraw message. Okay, so BGP route will be withdrawn. So now let's go to the CSS1. We will see, we will not see any update of the BGP withdraw or any kind of update, as this was the known best path. Let's jump to the CSS1. So here we are on the CSS router. I've already enabled the debug. If we check the show debug, so we have an debug update for the BGP update packets. There is no debug message. There is no BGP message, withdraw message received on the CSS, as we have shut down the interface for the known best path. So let's jump to the now CSS2, as route selector was selecting the path from the CSS2 best path. We'll shut down the interface from the CSS2 to XRV router 2, and we'll see that BGP update message will be reflected from the RR to this CSS also. So here we have the CSS2 device, and from this originator router only, router vector 1 was selecting the best path for the prefix 100.100.100.100. So let's take the BGP summary here. Okay, so we have an again 3 peering, 2 with the router vector 1 and router vector 2, and 1 with the eBGP peering. So let me check the route for this eBGP peering, and let me shut down the interface. I have shut down interface. Go to shut down. Let me do the commit. Shut down the interface. So ultimately this BGP will be down and this route will be withdrawn. So let's jump to the route vector 1. You can see that we were learning the 3 path and it was selecting the best path from the CSS2. Right? This is the best and group best. Right? Now again check this show BGP 100.100.100.100. You can verify that. Now we can see we have only 2 paths available. One is coming from the route vector 2 and one is coming from the CSS3, setting the best path. So if I put filter for the withdraw messages on this route vector, let me do the, I'm doing the filter on the withdraw message. Okay, here we can see that we're getting the update from the CSS2 BGP withdraw message for the 100.100 prefix, and we have shut down the BGP neighborship eBGP with the XRV router 2. And if I do the login 1.1, this is the IP address of CSS1. Here we can see that on the 650.38.167, it's getting a withdraw message from the CSS2, and immediate this update is got replicated to the neighbor. So it's further is sending a update to, as this was the best path. Let's log into the CSS1. On the CSS1, we'll also see the this kind of messages. So here we can see that on the CSS1 we have this updated route for this prefix from the CSS3 earlier. It was coming from the CSS2 as RR was selecting the CSS2 as a best path. And the show log also, we can see that the multiple BGP update to BGP messages. We can see that.